Morning everyone. Myself Priya RK, and I am a top educator in the category of EAMCET. I have been teaching on an academy platform from past 4 months for CET category. I also teach for different colleges in the offline mode from past 4 years for different categories like JEE, NEET, and CET. And I have given good number of ranks also under my guidance. So this is another platform where I'm working with Unacademy, and also I take YouTube sessions on alternative days, right? So regular classes will be there on Unacademy platform. So you can just follow me on Unacademy platform by making use of the link that is provided in the description box. As you can see at the bottom of this description box, there will be the complete details of my classes and also link to my profile on Unacademy platform. So all of you can just follow me on Unacademy platform and attend my classes regularly. And even you can refer your friends about this. Yeah. So this is about the plus subscription on the Unacademy platform. There are three different plans. One is a 12-month plan, which costs you around 12,375 rupees. And there is a 6-month plan, which costs you around 10,125 rupees. And also there is 1-month plan, which is costing you 2,250 rupees. And this is a trial price for the new subscribers only. Now, why we need to go for plus subscription and what are the benefits? Now, if you just take the plus subscription in this very affordable price by using this code PRKLIVE, first thing you will be getting 10% off on this any of the plus subscription. Okay, so use this code PRKLIVE, which is my code, to get 10% off on these plus subscription plans. Now under this plus subscription plans, you will be having premium content at very affordable price, and there will be live courses that will be organized for you people. Yeah. And dedicated live doubt clearing sessions will be conducted. Quiz will be organized at regular intervals for your self analysis and your understanding of the subject. And there will be a separate batch for the preparation of the topic or the subject matter, and daily practice papers that we call it as DPPs will be provided, and mock test will be conducted. Mock test will be conducted for analyzing yourself and your subject knowledge, and under a single subscription you can have unlimited access to the content on Unacademy platform. So if anyone is interested, please go for the subscription plan by using this code PRKLIVE and get 10% off. So thank you so much for this. Yes, welcome Shweta. Good morning. Good morning Chaitra. Good morning Prajwal. Good morning Vaishnavi, Pradeep. Very good morning everyone. Thank you so much for joining. Yeah. So let us just move on to the next part of this topic, that is electrochemistry. Good morning Aparna. Very good morning Sanjana. So that is in the last class we have studied about, good morning Gaudappa, different content, right? Different content of Faraday's electrolysis law, right? Faraday's law of electrolysis. The first law states that the amount of chemical reaction that occurs at or in any particular electrochemical cell is equal to the amount of current that is passed through the electrolytic solution. Second law states is that the amount of different substances liberated by passing same quantity of electricity is equal to or proportional to the chemical equivalent weights of the particular species. So these are the two laws which is relatable to Faraday's first and second law. Yeah. Now based on this, we have an equation to calculate the quantity of electricity that is passed through any given solution. So for this, the equation is quantity of electricity passed through any given solution is given by an equation. The equation is Q is equals to I into T. Q is equals to I into T. Now what are these different terms? This Q is nothing but quantity of electricity passed. Quantity of electricity passed. I is the constant current, and T, you know, it is nothing but time. T is nothing but time. Now what are the different units here? Time should be always in seconds, and current, as you know, it should be in amperes, represented by A, right? Amperes. And Q, quantity of electricity passed, is in coulombs. Coulombs, right? So which is also represented by C, right? So this is the formula to calculate the quantity of electricity that has been passed, right? So here we can use the Faraday's constant also will be required sometimes. So that is 96487 coulombs per mole. So you already know this value of Faraday. Okay, so let us just go for a question based on this particular concept. Let me just see if any comments from students. Good morning, Prathamesh. Good morning, Pranjal. Sachita, Shafakat, good morning, Sudham. Thank you for joining, all of you. Yes, and I can just tell you, people, that my videos are on YouTube are the most uh, viewed videos from past 1 week or even 2 weeks. You can just go to the category and check out the different videos and the number of views that are obtained by the particular lecturer. Okay, so thank you so much for all the support. Yeah, let us move to the question based on this particular concept. Okay, a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 amperes. What is the mass of copper deposited at the cathode? So let us see what is given in the question and try to solve this particular problem. Yeah. Now, a solution of copper sulfate is there, right? So, copper sulfate, you know, here copper is in 2 plus state and sulfate it is in 2 minus state. So, here copper 2 plus is going to accept the electrons, 2 number of electrons, to get converted into copper, because copper is deposited at the cathode. So, copper 2 plus ions from the solution, that is copper sulfate, is electrolyzed. So definitely it is a solution. So copper 2 plus from the solution is going to take up 2 electrons and get deposited as copper electrode, that is at the cathode, right? That is a reduction is happening here. Okay. Now electrolyzed for 10 minutes. So time given is 10 minutes. But as I said, this time should be in seconds, right? The time should be in seconds. So 10 into 60 seconds. So it will be 600 seconds. It would be 600 seconds. Next is with the current of 1.5 amperes. Means the value of what is given? Value of current is given, that is I is equals to 1.5 amperes. But we need the answer for quantity of electricity in coulombs, right? So first thing that we need to change this is in coulombs. So charge is equals to 1.5 amperes, that is Q, right? Q is equals to, let me write the formula if you need. So charge or quantity of electricity passed is equals to I into T, right? So I value is what? 1.5 amperes into time is 600 seconds. So this would be 900, if I'm not wrong, 900 coulombs, right? Now, according to this equation, how many electron changes are happening? 2 electron changes are happening. Therefore, we require 2 into F. F is nothing but Faraday's constant of quantity of electricity in order to deposit 1 mole of copper, right? This is 1 mole of copper. So for 1 mole of copper, 2 electron changes are happening. So charge of this electron would be Faraday, right? That is 96487. So we require actually 2 Faradays of quantity of electricity in order to deposit 1 mole of copper. So we require 2F of coulombs of electricity to deposit 1 mole of copper. So in the equation you can see that we are getting 1 mole of copper. 1 mole of copper is nothing but 63 grams of copper, mass of copper, right? Yeah. So 2 into F is how much? 2 into 96487, right? So this much coulombs of electricity is required. Therefore, for 900 coulombs, how much copper would be deposited? For this much coulombs of electricity, 63 grams of copper is depositing. Therefore, for 900 coulombs, how much is getting deposited? So let us just see. For 96487 into 2 coulombs, 63 grams of copper is deposited, right? Therefore, for 900 coulombs, how much copper gets deposited? That is the question. So, your answer would be, let us take this as X grams of copper is getting deposited. X grams of copper gets deposited. So, X is equals to 900 into 63, 900 coulomb into 63 grams divided by 96487 into 2 coulombs. So coulombs and coulombs gets cancelled. Whatever answer you get, that will be your final value. That is how much quantity of the particular copper is deposited. And the answer for this would be 0.2938 grams. So this is your final answer of copper that is deposited over the cathode. I hope that you understood. So charge required for this particular reaction is 900 coulomb. Now, if you pass 2 into Faraday's constant of electricity, that is why 2, because 2 electron changes are happening and 1 mole of copper will be deposited. So if you pass 2 Faraday of electricity, then 1 mole of copper, that is 63 grams of copper, mass of 1 copper mole is 63 grams. So this much coulombs will deposit 63 grams. That means the 900 coulombs will deposit how many grams? So just cross multiply it and final answer that you get is 0.2938. All of you can just cross check it and make sure the answer is right. Okay. Yeah. So that was one of the important questions from this particular part. Yes, good morning Mahalakshmi. Very good morning Bhagyashri. Thank you everyone for joining. Please practice these questions. It's very important. Yeah. Okay. Let us just move on to the next one. Okay. The next component here is about batteries. Okay. So batteries, as you know, you usually use it in daily life. So you use many different types of batteries. Okay. Many different types of batteries in your daily life, but you do not know that they are actually called as by a particular name. So what is a battery? Okay, so a battery is a device which converts chemical energy into electrical energy. So a battery is a particular device, electrical device, which converts the chemical energy into electrical energy. Now, where from this chemical energy is coming? This chemical energy is coming from the redox reactions. For example, if you take Daniel cell, there is zinc and copper are getting reacted to Z, that is Zn plus copper 2 plus gives Zn2 plus copper. So reduction and oxidation both is taking place. So during this redox reaction, the chemical energy would be released. So this chemical energy is converted into electrical energy by an electronic device called as battery. Okay, so that is the definition for battery. A device which converts chemical energy into electrical energy, and this chemical energy is obtained from the redox reactions. So there are two types of batteries. Okay, there are two types of batteries. And what is the difference between these two batteries? You can just look at into. So there are two types of battery. One is primary battery, another one is secondary battery. Now what is this primary battery? Okay, coming to this primary batteries. Primary batteries are those which are not rechargeable. These are not rechargeable. They cannot be recharged. Means if you use these battery once, it cannot be later on recharged. Means it cannot be used again. Once it gets utilized, you cannot use it back again. Okay, that is known as primary battery. Coming to secondary battery. What is the meaning of secondary batteries? Secondary batteries are those which can be used again and again. That means if you use it once, you can again recharge it and use it back. Okay, that is known as your secondary battery. So it has many different cycles of usability. Right. Now coming to this primary battery, let me just escape this. Coming to the primary battery, here what happens is, as I said, it can be used only once. Okay, this primary battery, it can be used only once. So coming to this topic of primary battery. So these ones used cannot be used again. Okay, they get consumed and they become dead and cannot be recharged. Okay, the most familiar one, the most widely used one is the Leclanche cell. Okay, it is named after the discoverer of this particular type of battery. That is the name of the scientist, Leclanche. So one of the example for Leclanche cell is, one of the example for primary batteries is Leclanche cell, and it is commonly used in transistors and clocks. It is used in transistors and even clocks, wall clocks. Okay. Now the cell consists of a zinc container that acts as anode. So what is the anode here? The anode is zinc. Okay, the anode is zinc. Okay, now at zinc, you know, oxidation takes place. So here oxidation reaction, let us just write Zn gets converted into Zn2 plus 2 electron. Release of electrons is known as oxidation. Okay, and the cathode is made up of carbon. The cathode, it is made up of carbon, especially graphite. Okay, it is graphite is another allotropic form of carbon, so I can just write it as carbon here, right? Okay, and this graphite rod, it is surrounded by manganese dioxide and again copper powder. Okay, it is surrounded by powdered form of manganese dioxide and carbon. So this cathode is in connection with manganese dioxide and carbon. So at cathode we know that reduction occurs. So let us see manganese dioxide how it is getting reduced. plus there will be a paste of, in between this cathode and the manganese dioxide, there is a paste of ammonium chloride and zinc chloride. Okay, so from there this ammonium ion is going to react. Okay, and the electron released from the anode, it is utilized here and it gets converted into MnOOH. Now, what is this MnOOH? Not only this product, and also you get ammonia. Okay, so after this cathode and between manganese dioxide, there is a paste of zinc chloride and ammonium chloride. Now, what is this component called as? What is this component called as? MnOOH. What it is called as? Anyone can comment in the comment section. MnOOH. What it is called as? So this is nothing but manganite. Okay, it is also called as manganite or manganese oxide hydroxide. Okay, manganese oxide hydroxide. Both are having the same name. Okay, both meaning is same. And ammonia is formed. Now you can just see here, manganese, here it is in +4 oxidation state. Whereas if you come to this one, it is in +3 oxidation state. So manganese had got reduced in this particular case. Okay, manganese has got reduced in this particular case. So this is one cell. Now here movement of electron takes place and this movement of electron results into a cell potential of 1.5 volt. So this cell has a cell potential of 1.5 volt. Okay, so very simple cell. At anode it is made up of a zinc container where oxidation takes place and zinc is getting converted into Zn2 plus and 2 electrons. The cathode is made up of graphite and carbon, which is surrounded by a powder of manganese dioxide, and there is also a paste in between these two electrodes, and that paste is ammonium chloride and zinc chloride paste. So here manganese dioxide is getting reduced to manganese oxide hydroxide plus from +4 oxidation state to +3 oxidation state, and the cell potential obtained from this particular reaction is nothing but 1.5 volt. Okay, so this is the same reaction. Right. Next one is mercury cell. Now this mercury cell is also very important. It is used in low current requiring devices like hearing aids, watches. Okay, hearing aids and watch. Now this consists of zinc and mercury amalgam as anode. Amalgam means any metal with mercury. If mercury is present, that we call it as amalgam. So zinc is present with mercury, so we can call it as zinc amalgam. Okay, you don't have to mention mercury. If you say amalgam, then definitely it means that mercury is present. So the anode is made up of zinc mercury amalgam, and there is a paste of mercury oxide and carbon as cathode. The cathode is made up of mercury oxide and carbon, and the electrolytic paste is potassium hydroxide and zinc oxide. Now what is this reaction that is taking place? At anode we know it is zinc amalgam, so it is going to get converted from zinc amalgam to zinc oxide by release of 2 electrons. So here definitely oxidation has occurred, right? Zn has gotten converted from 0 oxidation state to +2 oxidation state. Then here it is, okay, in zinc amalgam, let me mention it is in 0 oxidation state. Now coming to cathode, you know cathode is made up of a paste of mercury oxide and carbon. So this mercury oxide will take up these 2 electrons, and from +2 oxidation state to it is getting converted into 0 oxidation state, and therefore this is a reduction reaction. Now the overall reaction you can obtain by adding these two reactions, right? And what you get is zinc plus HgO gives ZnO plus Hg. The cell potential for this particular reaction is 1.35 volt, whereas in the previous cell you had seen it was 1.5 volt. So if it was more, but here as we mentioned in the previous section that mercury cells, they are used when low current devices are applicable. So it is low cell potential, that is 1.35 volt. So this is about mercury cell. Very good morning, Preeti. Okay, if anyone has a doubt, you can please ask in the comment section. Okay, yeah. Let us move to the next type of cell, that is secondary cells. Secondary cells are the one which can be recharged again by passing current through it in opposite direction. So a secondary cell is a best one which has a large number of charging and recharging discharging cycles, means the one which gives you more number of discharges and charging cycles, that is a better secondary cell. Now most of the secondary cells is a lead storage battery. So as the name suggests, it is made up of lead and it is used in automobiles, that is vehicles and inverters. And it consists of a lead anode, and the cathode is made up of a lead dioxide. And there is a 38% concentration of a sulfuric acid which is used as the electrolyte. Now, as the name, as we just saw, the anode is made up of lead. So the sulfate ions from the electrolyte will react with this lead and form lead sulfate by release of two electrons. So lead has got converted from zero oxidation state to +2 oxidation state. So definitely at anode oxidation has occurred. Then at cathode, as we mentioned, it is made up of lead oxide. So this lead oxide will further react with the sulfate ion, and the two electrons released from the anode, that is from lead to lead sulfate conversion, right? So let me just confirm if this, so here it should be lead dioxide, right? Yeah, lead dioxide plus sulfate plus 4 moles of H plus, which is released from the sulfuric acid, and 2 electrons which are released from the anode. And this reaction leads to the formation of lead sulfate and water. If you take the overall reaction, would be lead dioxide plus sulfuric acid plus 2 gives 2 moles of lead sulfate and 2 moles of water. On charging, the battery reaction is reversed, and lead sulfate is anode and cathode is converted into lead and lead dioxide respectively. Okay, that means once you, during discharge this reaction takes place, and during charging the opposite reaction takes place, means that reaction, that is the anode, will become the cathode and the cathode will become the anode, because flow of current will be in the opposite direction. So this is very important. Here 38% of sulfuric acid is used as an electrolytic solution. So this is how a lead storage battery looks like. You might have seen it in vehicles and even in inverters. Wherever inverters has been placed, you might have observed even this uh, structures. Okay. So another important secondary cell is the nickel cadmium cell. Nickel cadmium cell, which has a longer life than lead storage cell, but it is expensive. Okay, nickel cadmium cell, it definitely has a longer life than the lead storage battery. But if you just compare this nickel cadmium cell, it is more expensive than the lead storage battery, and that's how this is of less, what we should say, it is of, one second, yeah, it is of less usage made by people. The reason is because here what happens is, if you use this lead storage battery, it becomes costlier, and if it is costlier, then definitely people will not prefer to use it more, right? People do not prefer to use it more, and that's how people usually go for lead storage batteries. Okay, they usually go for lead storage batteries. Okay, now in this lead storage batteries, what you can observe here is, let me just mention here. Yes. Okay. So the overall reaction is cadmium here, which is anode and which is cathode, that we need to check. So here cadmium, it is the anode. From zero oxidation state, it is getting converted into +2 oxidation state, and nickel, uh, it is the cathode, and it is getting from +3 oxidation state to +2 oxidation state. So reduction is happening. So here +3 it is present in, and it is in +2 oxidation state. So this is how nickel cadmium cell looks like. Don't have to go for in details with the diagram because it's very complicated, but you should at least know that which is anode, which is cathode, and what is the reaction that is happening. So this is about the batteries, primary batteries, secondary batteries, and all. So my next YouTube live session is on 26th, that is day after tomorrow, and the date is, I think, Saturday, right? Let me just, yeah, it will be on Saturday at 9 a.m. And today on Unacademy platform, I'll be taking class at 10:45 a.m. to 11:45 a.m. And the topic is an organic chemistry chapter, aldehydes, ketones, and carboxylic acids. And there will be one more class at 12:45 p.m. to 1:45 p.m. So the interested students can attend, and you can attend your regular classes as well. Okay. Yeah. You can attend your regular classes. Yeah, thank you so much. If you have any doubts, you can comment in the comment section, all of you. If you have any doubts, you can comment in the comment section. Yeah, good morning, Preetham. Thank you so much for joining. Please refer your friends as well. Yeah, yeah. Thank you, everyone. I think there are no doubts. Let me just end up the session. Yeah, thank you and have a good day.